Hello everyone, let's simplify some complex fractions. When I look at this first example, to me it's a classic method 1 because the two fractions that we need to get rid of have the same common denominator. So multiplying by the least common denominator just gets rid of those two fractions immediately. So that would be my choice here. So let's do that. So that means I have to multiply the top by x and the bottom by x, which is the common denominator. So I'm multiplying by 1. So in the numerator, when I distribute the x, I take x times 3 and I get 3x. And then I take x times 2 over x. Well, what happens? The x's will divide out and I'm left with minus 2. Okay, so look what happens. Sweet, fractions gone in the numerator. I have a nice polynomial. So same procedure in the denominator. I'm going to distribute the x. So x times 2 is 2x. And then I take x times 5 over x. Well, if you think about that, that's x over 1. So the x's divide out, and I'm left with plus 5. Okay, that's the whole idea, is to multiply by something that the x will divide out. So now I can't simplify that rational expression, but it is no longer a complex fraction. All right, let's look at another example. And this one, I don't know, it'd be your choice depending upon your comfort level. But what I like about this is that I notice that the numerator is one single fraction already. So if I could get one single fraction or rational expression in the denominator, then I could just multiply by the reciprocal. So I think I'll choose method 2 here, but it does not matter. Okay, so I'm going to work in the denominator and I'm going to work on getting a common denominator so that I can subtract those two fractions. So my least common denominator for y and x is just the product of those two. So each of my new fractions are going to have a denominator, common denominator of xy. So then I have to multiply by whatever factor is missing so that I can get my new numerators. So I have a y, which means I have to multiply by x over x. So the first fraction. In the second fraction, I have an x, so I'm missing a factor of y. So I multiply by y over y, which leaves me with 4x in the numerator, and I can see where I would have xy in the denominator. The second fraction, I multiply 3 times y in the numerator, so I have 3y and the xy in the denominator. Okay, so I'm going to go ahead and simplify. Subtracting fractions with the common denominator, then we know the denominator remains the same, and we subtract the numerator. So I have 4x minus 3y in the numerator of that fraction or rational expression that is in the denominator. Okay, so if we think about it, this is our big fraction bar here. Whoops, that didn't show up so great. Okay, so in the denominator now, I have one rational expression or fraction. In the numerator, I have one rational expression or fraction. So what does a fraction mean? Divide. So ultimately, we're taking the top divided by the bottom. But we don't divide fractions. Remember, we multiply by the reciprocal. So I'm going to take, instead of taking the top and dividing by the bottom, I'm going to multiply by the reciprocal of the denominator. So I'm going to go ahead and flip that. The xy goes on top, the 4x minus 3y goes on bottom. So if you remember that copy dot flip. Okay, and now we're multiplying rational expressions. Multiplying fractions, get rid of common common factors. So I can see my x's will divide out, my y's will divide out. And then I can't simplify going the other direction, so I multiply across the top, which leaves me 3x minus 7 in the numerator and 4x minus 3y in the denominator. And there is my simplified rational expression. Okay, that was so much fun. Let's do another one. Oh, okay. Well, this is kind of cool. it's kind of similar to the last one. But I would definitely choose method 2 here, because when I see something like my denominator, it's not a rational expression, it's just a polynomial, okay? But it's one expression, so eventually I could think of it as a fraction, okay? So I could say, if I could get a fraction in the top, then I can multiply the reciprocal of the fraction in the bottom. Okay, so I am going to work on the numerator getting a common denominator so that I can subtract those fractions. Get one single fraction in the top. Okay, so my least common denominator, oh, is xy again. Sorry, not very creative. So basically then it's just missing the other variable. So here I'm going to multiply by y on top and bottom. And on this one, I'm going to multiply by x, so I get that denominator in both of those fractions of xy. So I get y over yx or xy minus, I get 1 times x in the top, and then in the bottom I would have y times x or x times y. Okay, let's go one more step. So I combine those into one single fraction. I have y minus x over xy, so there's my fraction in my numerator, and in my denominator, I don't have a fraction, but I could think of it as a fraction, as I alluded to earlier. So this is division. So we can say, okay, we're taking the top divided by the bottom, but we do not divide with fractions. So we take the first one, and we multiply by the reciprocal of the bottom. So we take the top times the reciprocal of the bottom. Think of that as x plus y over 1. So the reciprocal we know is 1 over x plus y. Okay, now I don't think I can divide out any common factors because this one's y minus x, and this is, we could say y plus x if we wanted, but they're conjugates, so not the same factor. So ultimately what we're going to have to do here is basically just multiply across the top. Y minus x times 1 is y minus x. In the bottom, we like to leave denominators factored so we can see that there are no common factors. So I'm not going to distribute the x, y, and then you can see easily that it is simplified. Okay, so here is my simplified expression. Notice no fractions in the numerator or the denominator. Oh my gosh, did we have one more? Oh, it's our lucky day. All right, so here I have 3 fractions, so I've got to get rid of them. I could show you this with method 1, but from my experience, when I show method 1 with this, people confuse it with method 2 and it gets a little scary. So I think students are more comfortable with method 2 in this situation. So I will go with method 2, which means in the numerator, I will get one single fraction. So I have to get a common denominator. The good thing about doing method 2 is I also review subtracting rational expressions. Okay, so remember, this is a binomial factor in the denominator. So I can't factor either one. So the least common denominator is the product of those two factors. X is a factor and x plus 3 is a factor. Okay, do not distribute because then you don't see what's missing. Okay, so then we do get the common denominator. So this denominator has x plus 3, so I need to multiply it by x to get the common denominator. So I do the same with the top. So I end up with x times 1, or x in the numerator. Okay, now the second one's where you got to be a little careful. I have x in the denominator, so I'm missing an x plus 3. So I'm going to have to multiply the top and bottom by x plus 3. I'm putting parentheses because there's 2 terms I'm multiplying by. So in the bottom we're good. In the top it's just 1 times x plus 3, or x plus 3. Okay. I'm going to keep going till I get that down to one single fraction. Okay, now be careful. If I see mistakes, here's where it is. You're subtracting. You're subtracting both of those. So basically, this is x minus 3. Distribute the negative sign through, and I end up with negative 3 in the numerator, and then my common denominator of x times x plus 3, which that is simplified. There's no common factors, numerator and denominator. All right, so then I'll just bring over my 1 over x, and now I have one single fraction in the top, one single fraction in the bottom. Take the top, multiply by the reciprocal of the denominator. Copy, dot, flip. You remember that. So the reciprocal of 1 over x is x over 1, or x. Now we're multiplying rational expressions. Fractions divide out common factors diagonally, so I can divide out the x. Nothing else can be simplified, so now I multiply across the top. Negative 3 times 1 is negative 3. On the bottom, I have 1 times x plus 3 times 1, which is x plus 3. And there you have it. Voila. Or is it voila? I don't know.